Hi Bobcats. In this video, I'd like to take a look at what happened in Flint, Michigan with their water supply. Before you watch this video, I really need for you to read this article. It's how lead ended up in Flint's tap water. This is an article from CNE News, or Chemical and Engineering News, which is a weekly news magazine produced by the American Chemical Society. It's a great overview of the chemistry behind what went on with Flint's water supply. If you go to Tracks Resources, it's in the Chapter 8 folder. If you read the book that was part of this year's Common Experience, it was called What the Eyes Don't See by Dr. Mona Hanna-Attisha. The crisis from that book is this exact same thing. It's what was going on with lead in the tap water in Flint. It's a very different point of view than our article because the book was written by a pediatrician and she was out trying to do what was right for her kids. So just what did happen there in Flint? Well, back in the summer of 2014, Flint decided to switch the source of the city's water supply. They had been purchasing it from Detroit, and Detroit's municipal water supply was already treated. They were selling Flint treated water, and it just was piped to Flint and then introduced into the Flint municipal water system. But what Flint started doing as a stopgap measure, because they were going to switch to a different supplier for a long-term solution, but that different supplier wasn't quite ready to go online yet. And so Flint kind of got themselves in a little bit of a pickle, and they said, oh, okay, well, if we're not buying from Detroit anymore, we can just take water directly from the Flint River, treat it ourselves, and throw it into our municipal water supply. So, water treatment is old, established science and engineering. People know how to take a natural water supply and do all the things that you need to do on it to make it a safe source for people to drink and to use in their homes. So something went wrong because within a couple months of this switch, there were all kinds of really bad things that started being noticed by their customers. All right, so here are some of the things that people started noticing. There is a bad taste and smell to the water. Water was yellow or red-brown at times. Industrial customers, like I believe the one mentioned in the article was GM, because Flint, Detroit, that's where the car industry is. Those places were discovering that various tools that they had that were in contact with water started corroding, and that was new. That had not been happening previously. On the kind of scary side, they had a couple of outbreaks of things like Legionnaire's disease and E. coli. And then Dr. Mona Hanna-Attisha found elevated levels of lead in blood samples from her kids. So people started figuring out, there may be something wrong here. I really enjoyed reading Dr. Mona's book because when you couple her description, her narrative of what happened with the article from CNE News, it all just suddenly made sense to me. Dr. Mona is a pediatrician and also a medical researcher at Hurley Children's Hospital in Flint. And as weird stuff is happening with the water, the families of her patients kept asking her if it was safe to drink the water. Well, Dr. Mona stuck with the company line initially. The government organizations in Michigan that were supposed to monitor that were all saying, yes, the water's fine. We keep testing it and everything is good. But Dr. Mona also knew that there are requirements that if children live in homes that have a high risk of exposure to lead, such as they were built before a certain date, which was when lead-based paints were phased out, then there's a pretty good chance that there is residue from those paints in the home, and they're supposed to run blood tests to see if the children are getting exposed to lead. And so Dr. Mona and her group went and looked at the lead tests that were being done, and it didn't take them long to discover this spike in blood lead levels that started shortly after the switch in the water supply source. Now, this whole thing created quite a dilemma for Dr. Mona. Think about the scientific process. She should do a complete study. She should look at all of the data that's available, perhaps do some studies to collect more data, do all the statistical analysis, and submit it to a respected journal, wait for the peer review process. At a minimum, that's going to take 6 months just for the peer review process, and it might take a whole lot longer. So should she announce her preliminary findings? Well, this is really a hard choice because as a scientist, if she skipped the peer review process and announced preliminary findings, and then it turned out that she just was seeing a weird blip in the data and a more extensive study didn't support that, she would no longer be able to get any kind of funding to do any sort of medical research. She certainly could still be a doctor, but she could not do medical research anymore. What was really the ethical choice here? This was really her dilemma. And there's a little bit more information you need. Lead's a neurotoxin, and it's particularly bad for brain development in children because your largest collection of nervous tissue is your brain. And so if kids are being exposed to lead, it really messes with their brain development. And let's not forget that there were some other weird things going on here, like people getting sick and even dying from the outbreaks of Legionnaires and E. coli. So Dr. Mona made the choice to forget about peer review. She actually announced her preliminary findings in a press conference because she felt that this was so urgent and it could not wait for the preliminary findings because her kids were being hurt. Okay, so let's take a look at this from the chemistry perspective. What was going on? Well, in water supplies, the pipes that deliver the water are often made out of materials like iron or steel. Steel is predominantly iron. They might be made out of copper, and they used to be made out of lead. And up until sometime in the 80s, the solder that connected one pipe to another could still have some component of lead in it as well. Back in the early 1900s up till I think it was the 1950s, you could still use lead pipes. Now, normally the lead stays put, or the metals, the iron and the copper will stay put. And what will happen is that phosphate will be added to the water supply, and that phosphate will react with the metal and it'll produce what I tried to draw as this little white ring here separating the water from the metal. This is referred to as a passivation layer. So more or less the metal reacts with the phosphate, producing the metal phosphates. It's basically like creating a layer of rock on the inside surface of the pipe. And so it's that rock separates the bare metal from the water and the metal stays put. But what was happening in Flint as research eventually showed, was, first of all, phosphate wasn't being added. Why didn't they add phosphate? Who knows? My personal opinion on this is that there probably were some discussions being held that went along these lines, and this is 100% speculation on my part. I kind of can imagine these conversations where somebody is saying phosphate, or orthophosphate's the buzzword for it in the industry. Orthophosphate, that sounds like a nasty chemical. Why would anybody want to put that nasty chemical into our water? And then somebody else would say, well, and it's really expensive too. So we know better than to put chemicals in the water, so let's just not put this in there and we're going to save a lot of money. Yay, high five. We just saved the city a lot of money. It's been a good day. So phosphate wasn't being added. And then the other issue was the pH. The pH was too acidic. And if you will remember from our chapter on pH, if something is acidic, it'll react with metals. Well, the acidic water also ate away that passivation layer. And once that passivation layer was gone, the acidic water started reacting with the metals, and that's basically redox chemistry, right? If you have a metal like iron in its solid form and it gets oxidized to something like Fe+2, and we'll put aqueous on there because it'll be dissolved up in water, or Fe+3, and again we'll put aqueous on there because it's dissolved up in water. Well, now you have a bunch of iron floating around, and that's going to be colored, and that's going to make your water have kind of a yellowish or reddish brown kind of color. If lead gets oxidized, that's going to go in as Pb+2, and then once that lead is in the water and your kids drink it, it can act as a neurotoxin. Also, what else did I want to get at? We can also explain the Legionnaires and E. coli outbreaks because there are various chlorine-containing species that work in these municipal water supplies to kill bacteria. But if the chlorine species can react or are exposed to metals, they react very quickly with the metals. And so the reaction of those disinfecting species with the metal was basically eating up or destroying those disinfectant species, and that allowed things like E. coli and Legionnaires to breed and grow in the water supply, and then that was making people sick. So where do things stand today? Well, there are still criminal proceedings underway for people who were in decision-making positions that resulted in the lead in the water. Still for years, people are going to be trying to track those kids and study the effects of that exposure. And when I just Googled Flint water 2020, there still are people who are questioning today, is the water safe to drink? So this is an ongoing issue for the city of Flint.